Okay, so recognizing graphs of arithmetic sequences. When we have an arithmetic sequence, the graphs will have a constant increase or a constant decrease. I'm going to call it a constant rate of change. Constant rate of change. So if we look at graph A, the x's are going up by ones. My x's are going up by ones. So if I don't have to make a table, but if I were making a table, my x's would be 1, 2, 3, 4, 5, 6. So my x's are all going up by ones. My y's are down by not quite 2. I'm going to guesstimate. I can't even exactly guesstimate that one. Then we go down by, oh, that's not 1 point. I'm sorry. It's like 0.9, maybe 0.8. There we go. So I'm just like guesstimating because I don't know the exact values. But since we're not going down by the exact same thing each time, that is not constant. So this would not be arithmetic. So let's look at B. The x values are going 1, 2, 3, 4, 5, 6. Are the y values changing in a constant rate of change? Do they have a constant rate of change? No. So not arithmetic. Look at C. We have x's are 1, 2, 3, 4, 5, 6. Are the y's changing by a constant amount each time? Okay, how can you tell that the y's are doing that, but they weren't on A and B? For B and C, I didn't even write down numbers. How can you tell, Brandon? Because it makes a straight line. And we know what that slope is. That slope is the rate of change. So to have a constant rate of change, it's going to be linear. Constant rate of change is linear. So is D arithmetic or not arithmetic? Belle, what do you think? D. Yes. It makes a line. It's arithmetic. Identifying arithmetic sequences. The difference of consecutive terms is constant. Now, we already know that when we have a sequence, we have 1, 2, 3, 4, 5. Our n values are always starting at 1 and are increasing integers, consecutive integers starting at 1. So that's already what we have if it's a sequence. So to tell if it's arithmetic sequence, we're going to figure out what the a sub n values are doing. So I'm going to find the difference from -9 to get to 2. If you can't do that in your head, there is a formula. There's a formula. It is a sub 2 minus a sub 1. So a sub 2 minus a sub 1 gives me positive 7. Right? From negative 2 to go to, from negative 9 to go to negative 2, we're going to add 7. Now, to get the next one, the formula would be a sub 3 minus a sub 2. So if I take 5 and I take away negative 2, I get 7. Is that the same for every single pair of numbers, every single consecutive pair? Is this one 7? Is this one 7? Okay. More of a general formula, I guess we could say, would be like A sub I can't remember how they say it in our book, but I'm making something up right this second now. A sub n plus 1 minus A sub n. So it would be like whatever n is, add the next one, or take the next one first, then minus the first one. I'll look it up and see in our book. I'll look it up. See in our book what exactly it looks like, but something like that. All right, so this one is arithmetic. And you have to say why in your assignment. Arithmetic. John, can you give me like a good reason why that's arithmetic? What is constant?
I don't know what you call it, like count 7, like you're adding 7 times.
A common difference. There is a common difference. Or you could say the difference is constant. Okay, but this right here, common difference, is a vocab word, so I'm going to use it. It's written right above. It says, this constant difference is called the common difference, and it is denoted by D. So there's a D value that we're going to find when you're finding that constant difference, that common difference. The D value would be that common difference or that constant difference. Oh, it doesn't really give a formula. I was trying to look up this right here. That's why I couldn't remember it. It just says like A2 minus A1 or A3 minus A2 or A4 minus A3. That's what it says in the book. Just has a bunch of examples of what how you would get those values. All right, question B. Is it arithmetic? So we do 15, take away 23. We get negative 8. And we do 9 minus 15. Negative 6. 5 minus 9. Negative 4. 3 minus 5. I mean, I really don't have to do any more because I already know the answer. Negative 2. This is not arithmetic. This is not arithmetic. What is it, by the way? It is quadratic. Because if I went further, which I'm not going to, but if I went further, I would have 2 levels of finite differences, and that would mean it's quadratic. So this is not arithmetic. So extra information, it is quadratic. It has to be linear to be arithmetic. And we could say for the reason not arithmetic is it doesn't have a constant difference. So you want to like just justify your answer somehow. You could show your work and say not a constant difference. Just justify your answer when you do these in the assignment. All right, take a moment. See if you can figure out which are arithmetic, which ones are not. Explain your reasoning. Okay, so mine, I had number 1 and number 2 being arithmetic. I have my constant difference written down, or the common difference, sorry, the D equals 3 for number 2 and D equals -6 for number, oh, I said it wrong. For number 1 is D equals 3 and number 2 would be D equals -6. And then 3, it's not arithmetic because it's not adding or subtracting the same thing each time. I also can tell that this is exponential. Can anybody tell why it's exponential? So we're dividing by 2 or we're multiplying by half each time. So when we think about exponential, we want to think about multiplying. So each time multiplies by a half. Okay. All right. So now here is a rule for an arithmetic sequence. This means if you know it's arithmetic, you no longer have to guess and check. There is a formula for it. So if you can identify right away that the equation or the sequence you're given is arithmetic, then boom, you have a formula. This formula is for a sub n. You do the a sub 1. What's a sub 1 stand for? What's a sub 1? Lydia, what's a sub 1? The first term of the sequence. Yep. Oops. First term. And then we've got n minus 1. What's n minus 1? Or what's n? The number term that you're sitting at. Or it could be like how many terms total there are if the sequence ends. But yeah, which term number? Take away 1. So I'll just say 1 less than the term number. And then D stands for our common difference. And so then they just have an example. If we have the first term is 3 and the common difference is 2, then we would plug in 3 in the first term. We'd plug in 2 into the common difference. We would distribute that 2 and combine like terms, and we would be left with a sub n equals 2n plus 1. So that's what you're going to do for a little bit. Write a rule for the nth term of the sequence, then find a sub 15. So first of all, we want to find out of its arithmetic. So we say plus 5, plus 5, plus 5, D equals 5. This is arithmetic. So my formula, until I have it memorized, I write it. A sub n equals a sub 1 plus n minus 1 times D. So until I have it memorized, I'm just going to keep writing it. A sub n equals 3 plus n minus 1 times 5. So I get 3 plus 5n minus 5. A sub n equals 5n minus 2. So there's a sub n. Second thing is, let's find a sub 15. So that just means input 15 for the n. So we'll do 5 times 15 minus 2. So 75 minus 2, 73. Super hard stuff, right? Too hard for last 10 days of senior year, John? Really? Okay, so the next one, we find our common difference. I do a sub n equals a sub 1 plus n minus 1 times D. So today is all about a formula. Way less thinking than we've been doing. Actually, it's about 2 formulas today. Anybody have any questions over these? All right, try one on your own, totally on your own. The sequence 7, 11, 15, 19, find a sub 15. You got this one? Yeah. In your head? Okay. Make sure you have the a sub n part because that would count it wrong. And then the 15. Lena, did you get the rule? Did you get? Good. And Nick, what'd you get for a sub 15? 63. Excellent. All right, next is writing a rule given a term and a common difference. So now we're given that a sub 19 is negative 45. And then we're also given that the common difference is negative 3. We're going to write the nth term and graph the first 6 terms of the sequence. Uh-oh. There we go. So if I know that a sub 19 is negative 45, I can use, I don't know why that keeps happening. I can use a sub n equals a sub 1 plus n minus 1 times d. And I can plug in the information that I have. So a sub n would be a sub 19 is negative 45. A sub 1 I would not know, but I know that n is 19. So I'm plugging in the 19 into the n spot, and a sub n is what it equals, negative 45. Oh, and I know my d. Sorry, I forgot to plug in the d. What was the d? Negative 3, thank you. So then I get 18 times negative 3, which is negative, is it 54? 52? No. What is it? 54? Yeah. So we get a sub 1 is 9. So a sub n equals 9 plus n minus 1 times negative 3. So I get negative 3n plus 3. Since we're doing sequences start at 1. We're not going to use the left half of the graph. 1 is 9. How should I'm sorry. Yes, I went the wrong way in my head. Sorry, thank you. That's why I shouldn't do stuff in my head. Okay. What should I count by on the y-axis or the a sub n axis? Any ideas? Threes? Maybe. Any other better ideas? I'm sorry. What are our answers going to be? First term is 9. What's the second term going to be? 6. Okay, so we want to count by threes? That sounds good. I just need to fix my graph, though. You guys think that's a good idea? Because we can make it whatever we want, yeah? Okay, let's do it. So we've got 1 is 9. 2 is 6. 3 is 3. 4 is 0. 5 would be 3, or negative 3. And then 6 would be negative 6. Should I graph 12? The y-intercept, should I graph it? Caleb, what do you think? Should I graph the y-intercept? The y-intercept at 0, 12?
No, because the first term of the sequence is 1.
Right. The first n that we're going to graph, this is our n right here. First n we're going to graph is 1, and then a sub n would be what you get out of it. And we're not supposed to have a 0 term. What about connecting it? Should we connect it? Not for sequences. We're going to leave them as dots. What we're really just confirming is that we have a line and that they are spaced evenly. We can see they're going down 3 each time. Okay. Example 4 would be the most amount of work of any of these, writing a rule for a given 2 terms. So I'm given a sub 7 is 17 and a sub 26 is 93. So what we're going to do is we're going to, and this is what I'm going to ask you to do, even if you can do it in your head, I'm going to ask you justifying your answer with this method. So I'm going to write it down what we're doing. So you're going to justify your answer by solving a system of equations. We skipped the system of equations chapter because of our lack of time this year. So we are going to put in a little bit of solving systems here. So again, it is important that if you can do it in your head, great, but I want to see that you know how to solve systems. And if you already know the answer, it should be really easy to justify your work. So what we're going to do is we're going to have 2 equations. So we'll have equation 1, at which I'm going to use a sub 7, 17. So I'm going to have 17 equals a sub 1 plus, and then my number of terms is 7 minus 1 times d. Now, I do not know a sub 1, and I do not know d. And then we're going to have equation 2, which is 93 equals a sub 1 plus 26 minus 1 times d. And I do not know a sub 1, and I do not know d. So we have 2 equations and 2 unknowns. If you have enough equations that it matches the unknowns, we can use systems to solve this. The number of unknowns, the number of variables, you have to have that many equations. So if I had 3 unknowns, I'd need 3 equations. Our choices for solving with systems would be by substitution or elimination. So for this one, I think I'm just going to do substitution. And I do know that this answer is 6, as this is 25. I'm just going to use that in my substitution. So for equation, maybe I'll try both of them. For equation 1 and 2, I'm going to say, I have no idea why it keeps opening another tab, because I'm not touching it. Okay, I'm going to say a sub 1 equals. So when we solve by substitution, we want an equation that is one of the variables equals. So you could just make one of these a sub 1 equals, or you can do them both. It doesn't really matter which option you choose. So if I use equation 1 and I make it a sub 1 equals, I'm going to get 17 minus 6d. And then for 90, the a sub 1 with a 93 minus 25d. So now I have two equations. They're both solved for a sub 1. Again, it could just be one of the equations solved. What we do is we take a sub 1 in one of them, and we substitute it for a sub 1 in the other. So my substituted equation is going to be 17 minus 6d equals 93 minus 25d. At that point, I only have one variable. I can solve it. So let's see. I'm going to add 25d. And I'm going to subtract 17. Does that go evenly? So I solve for d, I have my common difference. Once you have one of the variables, you're going to plug in into either original equation. So I will plug it in, number 1. 17 equals a sub 1 plus 6 times 4. And I get a sub 1 is negative 7. If you want to make sure that you're correct, you can check it in other original. So I would check it in, can't see it, sorry. It's like 93 equals negative 7 plus 25 times 4. So 93 equals negative 7 plus 100. Yep, that checks. So then our equation, or our nth term, is that what we have to do? Find the rule. Yep. Our nth term would be negative, oh, nope. That's not our final nth term. I'm gonna write it smaller and then solve it. So our final nth term would be 4n minus 11. You guys remember doing substitution in previous courses? We have a whole chapter of it that we skipped this year. We skipped substitution, elimination stuff, and then we also skipped matrices this year. That's what we ended up skipping. Okay, so there are 2. Pick one of them, try it. Pick one of them, try it. Pick one of them, try it. I want to see that you can do substitution. So do the substitution. So graphing those first 6 terms, you can see from this first one that 1 is negative 27. I didn't draw a good graph. Should have thought about that before I drew my axes. and that we're increasing by 7 each time. So I saw a lot of you making this harder than you need to. There's 28, negative 21. So I'm going to count by 7s on my y-axis. So at 1, it's like negative 27. Now I just have to add 7 each time for 2, 3, 4, 5, 6. I just have to add 7 each time. So I'm adding 7 and I get negative 20, except for I can't. I gotta like stare right in front of it in order to line it up. And then I add another 7, and then I get negative 13. And then I get negative 6, and then I get 1, and then I get 8. So I don't really have to plug in each of those numbers. I like find my first term, and then I just add 7 each time. So I'm going to do the same thing on this one here. We should have a sub n equals negative 5n plus 106. I probably made this way too big, but I'm counting by 10s. So then I've got 106, and then I'm going to just subtract 5 each time. So from 106, I'll be at 101. And then for the third one, I'll be at 98, right? No. 97? No. 96. I don't know where I was going with that. Because I'm trying to do it in my head and not thinking clearly. So then we'll be at 91. And my graph looks terrible because I'm not lined up very well. After 91, then we'd be at a 6 again, 86, and then at 81 and so on. There you go. So you really shouldn't have to spend a lot of time plugging in numbers. You just like find that first one, subtract 5, subtract 5, subtract 5. Okay, this right here was in yesterday or last class's assignment, but I didn't really introduce the entire equation to you. We did one that looked like this. We did, it was n times n plus 1 over 2, which works if you're adding consecutive numbers. So this is going to work for any arithmetic sequence. This does not work for any sequence. This works for any arithmetic sequence. S sub n stands for the sum of however many terms in that sequence. S stands for the sum of, and it says the first and nth term. No, that's not what it stands for. The sum of n terms. That's what it stands for. And then we have n, which is the number of terms. We multiply that by the first term plus the nth term, divide by 2. And that will automatically give you the sum of all those terms. Or you can do it by hand, but you don't actually have to write out every single term to do it. Only works for arithmetic. You do this to other kinds, it's not going to work. Only works for arithmetic. So here I want to add together the sum. We're going to have our i's going from 1 to 20. So I personally do not want to add up 20 terms, and this would be a non-calculator question. So I can't just type it in my calculator. So we are going to find a sub 1. We're going to plug in 1 for I. And we'll get 10. We're going to find a sub. How many terms total are there? How many terms total are there? There are 20 terms. So I'm going to find a sub 20. And for this, that'll be plugging in the number 20. So I have my first term and my last term of the sequence. So S sub n is n multiplied by a sub 1 plus a sub n, divided by 2. So we have 20 terms. We're going to do 10 plus 67, divide that by 2. And you know what? The formula in our pre-calc book, I believe, is actually, it's the exact same formula. It just looks different. I'm going to write it this way. Okay, so this is the way the formula looks in our pre-calc book. It doesn't really matter which one you're dividing by 2. You just have to divide by 2 at some point. So when I look at this equation, I've got 20 multiplied by 77 and then divide that by 2. I'm going to actually use the 20 instead of the 77. A little bit easier. So I get 10 times 77, which is 770. For my sum. Okay, so I'm just like looking ahead at these questions. This is where people are going to mess up, and I don't have one like this in here, unfortunately. So I'm going to change one of these questions. I'm going to just change one of these. Let's do the first one. I'm just going to change it. You guys can change it with me. I'm changing it so that it's actually going to start not at the first term. Because I know there's some like this in your assignment. So if we have something like number 7 here, what would be the number of terms? It's not 7. It's not 10, no. So we'll have like plugging in 3, plugging in 4, plugging in 5, plugging in 6, plugging in 7, plugging in 8, plugging in 9, plugging in 10. How many are there? There's 8. Now, if I go back to, well, the one we just did had like a I equals 1 to 20, and you guys told me 20 terms. Did we subtract 20 minus 1 and get 20? No. So you don't just subtract 10 minus 3 and get 7. So can we like maybe think of a way that we could take these two numbers to find out the number of terms that works for both cases? Yeah. What I've done in the past, so exactly what you said works. What we've done in the past is subtract the numbers. Subtract, I'm going to call it upper minus lower, and then plus 1. So you could add 1 to the upper and then subtract the lower. That works too. You just got to add an extra number in there because we're including that first number. We're not finding the difference between the two. Okay, that's one place where people make mistakes. So let me do number 7 with you, where the first term is not plugging in 1. So number 7, my a sub 1, we actually plug in 3. And then my a sub 8 will be my last term, but I plug in 10. Okay, so that number of terms is what will get you if you're not paying close attention. And then we do our formula, which says S sub n. And I will do the number of terms. I'm going to multiply by 27 plus 90. And then I'm going to divide that by 2. Oops, I forgot to write in the number of terms. That was my formula. I was writing and then I got, nope, it's not 8. I mean, it's 8. So remember the formula, S sub n is the number of terms, a sub 1 plus a sub n over 2. So I plug that in. I'm going to divide my 2 from the 8. So I get 4 times 117. So maybe I'll do 4 times 100 plus 4 times 10 plus 4 times 7. Since this would be non-calculator. Did you guys ever do this in previous? Like this is what they teach the young kids nowadays, is like by place value. It's just the distributive property. I just did 4 times 100 plus 10 plus 7. And then I distributed the 4 to each of them. I just did it so I wouldn't have to like multiply it all out in my head. This I can add easily. 468. Never seen that? It's very helpful if you have to do things by hand. Okay, and then the last stuff that you're going to have would be word problems. So let's look at the solving a real life problem. You're making a house of cards similar to the one shown. Has anybody ever done that? I can't get in the stands. I can't do it. Right, I don't have enough patience. Write the rule for the number of cards in the nth row when the top row is row 1. So for row 1, how many cards do we have? I was going to say, I think it's the 3, but maybe I don't know. It might be. Do I have it open on here? Oh, no, this crashed earlier. I'll look it up.
Probably 312.
Huh?
Probably 312, right? That makes sense.
So 3.
I think it's including a lot of like cards.
That's what I'm guessing, but I don't know for sure because they didn't show it by itself. So I'm just double checking. This is an example that they did in the book. So I'm just going to double check and see if they used 3 as our first term. Yes, 3. Okay. So they're just using those first 3 cards for the first row. So then what are we adding for the next row? 1, 2, 3, 4, 5, 6. So adding 3. So we'd have 3, we would have a sub 2 would be 6. A sub 3 would be 9. So our common difference is 3. How many cards will we need to make a house of cards with 12 rows? So we have a sequence, 3, 6, 9, ... We want to find the sum from the first layer through the 12th layer. So I need the equation that I'm plugging those into. So 3n, what's the rest of it? So we could do a sub n equals 3 plus n minus 1 times 3. 3 plus 3n minus 3. So I get 3n as my a sub n. So just 3n. So we know that our a sub 1 is 3. Our a sub 12, we're going to have to figure out. So we'll do 3 times 12, which is 36. So we'll use that sum formula for 12. Do 12 times 3 plus 36 over 2. So I have 6 times 39. All right, I'm going to do that. I'm going to do that trick again. The distributive property. I'm going to do 30 plus 9. Okay? Actually, there's an easier way to do this one. You can do 30 plus 9. That's totally easy. But I'm going to do 40 minus 1. Doesn't that make 39? What's 40 times 6? 240 minus 6 times 1, 6. So 234 cards. You see my mental math? Huh? I don't know. I think that method is so helpful. And I think that's it. So on the last class's assignment, having this formula would have been pretty helpful for some of them. So it's not due till tonight. It was just like the last, I think it was like 60 to 80 even maybe, or 60 to 82, 60 to 82. This is the last little bit. You probably want to use this formula for a bunch of them. And then you have another assignment. I took questions and I made it into a worksheet for you. I mean, it's just, they're not numbered in order. I just screenshotted everything, but I just did that to make it a little bit easier for you to just have a paper where you can do all your work and find answers.